4.1, solving a 2x2 system of linear equations by graphing. And when we talk about what we call a system of equations, right now it's 2x2, which means we're looking at two equations for two separate variables. Now, solving a system by graphing is, I hate to oversimplify this, but, well, no, I'm good oversimplifying it, actually. I would prefer to oversimplify it. All we're going to do is graph two lines and see where they intersect. Where they intersect is the solution to what we call that system, okay? Yeah, that's what it says. The solution is found at the point where the two lines intersect. So think about it like this, okay? So if I go to this graph and let's emphasize this here. So let's say I put, oh, that's that happened right there. Let's make this line right here, okay? So this line, now remember that every point on the line would make whatever this equation is, whatever the equation that would make this line true, right? So if we graphed, let's say it goes through this y-intercept right there. That looks like 0, 2. Whatever the equation is, if you entered 0, 2 into that equation, it would give you a true statement, right? So if you look at a point like that's up here, that's going to give you a false statement. Just knowing that much about lines and graphs and ordered pairs and equations and how they relate to each other is crucial, especially when we start looking at these 2x2 systems of equations. So like the orange point, again, what is that, 3, 9, that would make the equation false. So let's go back here and let's go to this purple line, okay? Now I'm going to make another line, and if this was a system, because it is, so because you got a purple line, you got a blue line now. The question that I would like to ask here is this green point the solution to this system of equations on this graph? The answer is no. It is on the purple line, but it needs to be on the blue line as well, because a solution to a system of equations will not only make one equation true, but it will make both equations true. If it's false for both, and there's so many ordered pairs that would be false, like this one, -8, 0, that would be false. Not just for one, but for both. 5, -6, right here, yeah, that's false too, okay? Now you could say, well, what if we go to an ordered pair on the blue line, like this one perhaps? Let's call that 8, 9. Okay, now again, it makes the blue equation true, but the purple one false. So the solution to a system of equations is where these two lines converge and intersect, okay? So that would be right here. There's a fractional value, not that we care, but this red ordered pair, whatever it is, it would make the purple equation true and then the blue equation true as well. And that is how we find the solution to a system of equations by graphing. Graph two lines, you check, you see where the two lines intersect, and then you're done. So as long as you can graph, you're in good shape. If you can't graph, then this is going to suck pretty bad. It just means that you need a little bit more practice, that's all. Well, I guess it can still suck even if you understand it because it's math. I get it. All right, so here we go. We got these two equations right here. Let's I'm going to cover the second one just so we're not distracted by it, okay? So here I got two equations, and we want to see if this ordered pair would make both of them true. If it makes any one of them false, automatically it is not a solution to this system. And remember, a system of equations is just when you got two or more equations that really we would want to be equal to each other. So let's write this out over here. Now we got an x minus y equals 3. And in this ordered pair, I got an x value that's 4, a y value that's 1. So let's replace the x and y with 4 and 1. So 4 minus 1, would this be true? Yeah, because 4 minus 1 is 3. 3 does equal 3, that's true. So the first equation gives me a true statement when I replace x and y with 4 and 1. How about the second equation? Well, that's 2x minus 3y equals 5. So let's replace those two values, x and y, with the numbers that they gave us in the ordered pair, where x is 4 and then the y is 1. And we'll check this one also for truthfulness. 2 times 4 is 8. 3 times 1 is 3. Does this equal 5? Yep. 5 does equal 5, at least for now. And that's true. So I got a true statement on both, which means that yes, for 1, the ordered pair is the, I guess, the solution. Now this means, again, if you were to graph these two, equations. Let's see, negative x plus. So on a graph like this one, we'll make this one purple. It'd look, I guess, something like this right here. And then we'll do this one in orange. Just choosing those colors randomly. 2/3. And then, I guess it'd be, I don't know, something like this. Yeah, I'll try to make that a little bit better. Something like this, okay? So 4-1, I should do that better. 4-1 would be, I guess, somewhere in this direction right here. This right here, this activity that we just did, I guess if you want to call it an activity, this is what you would do after you found that the two lines intersect, okay? Because it would say, hey, look at this point right here at 4 and 1, right? And then after you saw that this is where they intersect, then you would go back to the two equations. And as far as I know, we don't require this on any test, quiz, or assignment. But should you do it? Definitely on tests, which unfortunately I did not see a lot of on the last exam. If you're doing it on a calculator, that's fine. Just hopefully you're doing it, right? Although sometimes the answers are wrong, so clearly you're not checking. But yeah, you'd get your answer here, and then you'd go in here and check, okay? But I highly encourage doing this step because, yeah, that's why it's on the homework. That's why we're emphasizing it right now. Here's that second one right here. So new values, okay? And we got new x and y values too. Let's check these equations. So 3x minus y equals -12. All right? And it says that x in the ordered pair there is -3. So I replace x with -3. I replace the y value with 3, and then I check for truthfulness. All right, well, 3 times -3 is -9, minus 3. Will this equal -12? It looks like it. -9 minus 3 is -12. Yep, so that's going to be true. Now, hopefully, we have more persistence than to just be like, hey, that was super fun. And it was. It was like, hey, that made me feel good inside that it was true. But we got to check the second one, right? X minus y equals 0. Now, if by chance we found that this one was false, we're done, and we say that's not the solution, okay? Automatic. It doesn't matter if it's on this line or not. But I do x minus y, and I replace the x with -3, it looks like, and then the y value with 3. And then here we go, check for truthfulness. If you do this in your head, it's a common error to say -3 minus 3 is 0. It's not 0. It's -6. So be careful. And if you need to use a calculator for that, please don't feel ashamed to do it. No, I highly encourage calculators. Now, this is false, though, for now. So -6 equals 0 is false. So automatically, even though this one was true, that means that -3 is an ordered pair on the line for this equation. But it doesn't fall on this line right here, okay? So that means that if you were to graph these two lines, I don't know what the crap they look like, and I don't really care right now. But -3, it would fall on the purple line about right here, but the other line, you know, it wouldn't, okay? But we need the intersection of those two lines. Now you'll see once we start graphing that usually the solutions come out very, very pretty, right? No decimals, no fractions. So what do we do when there is decimals and fractions? There's other strategies, and pretty much, at least in the past, they didn't require you to use specific methods. Will they on the next exam? I don't know. We'll see. Moniker there. Okay, so graphing, right? We know we need only two things to graph. We need the y-intercept and the slope. And if we can just change it, if we ever see an equation that's in standard form, we can use principles of equality to change it into slope-intercept form, okay? Again, that's just where we would solve for y, and then the m is the slope, and the b is the y-intercept, okay? So once you see this equation, in any equation in slope-intercept form, you'll have a point to choose from to put on the graph, and then you'll be able to find the slope, or use the slope to find all the other points on the graph, okay? Now, of course, in the past, we only did this with one line. Now, with the systems of equations, we're going to be able to graph two lines because it was so fun. So, but those are the only two things you need in order to graph, well, linear equations or straight lines. So here we go. Now, these two are both, just to start out, they're both in standard form. So going to go ahead and switch them into slope-intercept form. Could you, if you wanted to, could you have just graphed these with a table? Yes, you could. But it'd be really nice if you started to get used to the habit of changing these into slope-intercept form. So I'm gonna take this equation up here at the top. That's the first equation, and I'm gonna solve for 4y as usual, which means that I would need to subtract x from both sides.
Hey,
Like
stop.
this, right? Now on this one, that's gonna zero out my x right here. Now on the right side of that equal sign, I'm gonna show it as negative x, and then we'll show that as plus 2, right? And then I'll drop this negative y equals negative x plus 2. And then I don't want negative y though, so I'm gonna divide all the terms by negative 1. And yes, some students would just say, aren't we gonna just change the signs? Pretty much. So that would give us y equals, that's gonna be phantom 1x. I'm gonna show the phantom 1 though, and then it'd be minus 2, okay? So just from this, now, that it is in slope-intercept form, I now have a y-intercept to graph, which is at 0, negative 2. And then I also have my slope, which is 1, but I'm going to show it as 1 over 1, just because I know then that how far up and, well, in this case to the right, up and to the right. Up 1, to the right 1. Okay, but it's up 1 to the right 1 from that ordered pair, 0, negative 2. And so this equation here is going to be my red line, okay? So 0, negative 2. Let's see if I can get that on there. Wrong tool. There we go. Right, then it says I go up 1 to the right 1, so I can show the stair step. Boom, there's the next one. And if you want to show
Oh, you're showing
all
me
the
different
stair
ways.
steps, that's fine, but you don't necessarily have to. Some of you, I think, would kind of get the pattern at this point and say, well, I just got to continue the stair step this way, and then you could even, if you wanted to, continue the stair step in the other direction if you wanted to show all the points. Now, of course, on Canvas, are you going to have to show all the points? No, you just need 2 points, and then it will graph the line for you, okay? But since I'm doing this by hand, I kind of want to see all the points, even though it was more work than I wanted to do. Now, am I going to connect the points? I will. I'm just not going to do that yet. And here's why. Because I'm graphing this, I expect that the other line, which I will do in purple, I expect that this line will intersect somewhere on this graph, right? Because otherwise, they'd be really jacked up if they did this, especially this early on. All right, so this other equation, once again, I'm going to solve for y. It's always solving for y because slope-intercept is y equals mx plus b. So I'm going to have to subtract the x from both sides, and again, just to keep this in slope-intercept form, I'm going to put the x term in front, and then the 6 that's positive, I'm going to move to the right there. So I'll drop the 3y as well. And then the last step here, just divide all the terms by 3. So it may be helpful to see that phantom 1 with the x, or negative 1. So that's a phantom 1 right there, just like we wanted. Now y equals, I'm going to show it as negative 1/3 x, and then 6 divided by 3 is positive 2. All right? So I was able to fit it. But now that we have that in slope-intercept form, I can see that my y-intercept, that's the first thing I would need, because that's the ordered pair on the graph. That's going to be 0, 2. And then the slope here, the coefficient of x, which is showing as negative 1/3. Again, for me, I like to make the numerator negative and then the denominator positive. If I need to switch it just because of its location, we may see that, but then I know I can or will. But since it's a negative 1 in the numerator, that's down. That's the rise, which is now down 1. And then the 3 in the denominator is positive, so I will go to the right 3 from that ordered pair at 0, 2. So let's put 0, 2 on the graph. I can get this on there. 0, 2, boom, right there, okay? And then it says, all right, go down 1, there's down 1, and then to the right 3, boom, I can already see the intersection, okay? And I'm gonna put that in a different color, just so we can see that it's the point of intersection between the 2 lines. But because I'm a math nerd, I'm going to put the other points on there. Down 1 to the right 3, down 1 to the right 3. There we go. And I can follow these stair steps to the left as well. Left 3 up 1, left 3 up 1, left 3 up 1. Okay, so this creates our 2 two lines right there. Hopefully you can do them by hand better than I am, but it should work. Something like this, okay? And again, the green ordered pair right here. Oh, that's at 3, 1, right there. This would be the solution to our not just one equation, but both, right? That would make both equations true. Let's check. So in the first equation, in red, that'd be 3 minus 1. Does that equal 2? Yep, that's true. About the second one, 3 plus 3 times 1. Yep, that'd be 6. That's true. So see how we just kind of check that. You don't have to necessarily show all the work, like I was saying. Some of you have chosen to do that in the calculators, which is great. But since I can see that these are both true, then I know for sure that I've not only found the solution, but that I probably graphed these correctly as well. Yeah, I'll emphasize that. Sorry about that. The solution here, 3, 1. And yes, it should be shown as an ordered pair. On the homework, it may ask the x value and y value separately and in separate boxes. Sometimes it will show it as an ordered pair, and then like this would be a box here and this is a box here. So they'll provide the parentheses and the comma, but again, other times they'll do that separately. All right, so on this one, okay, I'll do this first equation in red. It'll be my red line, and yes, it's already in slope-intercept form. If you don't know, hopefully you will eventually, because it's crucial that you do notice that the y-intercept here will be 0 from the plus 0 part, which is just phantom plus 0, okay? So from that, I know that my y-intercept is at the origin 0, 0, okay? Because the plus 0, even though it's not shown, and you don't have to show it, but it's important you know that that's there so that you know what's being added to the negative 3x. And then we know the slope here is showing as, it's just showing as negative 3. I'm going to show it as negative 3 over 1. Again, the 1 is positive in the denominator. The negative for the 3 makes it go down 3. That's our rise, down 3. And the 1 that's positive will make it go to the right 1. From our ordered pair, the y-intercept at the origin, 0, 0, right here, okay? So from there, down 3 to the right 1, okay? And I just can't leave it alone. I got to graph all of them. Not quite like Pokemon, but somewhere in there. So left 1 up 3 as well. That gives me all these points. And again, I'm not going to connect the points yet. I mean, you could, but I should expect that this next equation, which I'll do in purple, to intersect somewhere in there, okay? But first, I'm going to take that equation and I'm going to solve for y, okay? So kind of leave that alone, but that means I got to subtract the 6x from both sides. And again, I'm offsetting that just a little bit this time to show that they're not like terms that I can combine, but I will still put the x term first, and then that's plus 4. I'll drop my 2y, which now equals negative 6x plus 4. Just finally dividing all the terms by 2 to make the coefficient of y a phantom 1. And we get y equals negative 6 over 2 is going to be negative 3x. And then 4 divided by 2 is plus 2. Now, if you understand what's happening right there with just the equation and the red equation, then you could pretty much stop right here, although, of course, on the homework, they're going to ask you to graph. But first thing on this one would say, what's the y-intercept? We've talked about this in the previous unit, by the way, the final solution to this one. But this is 0, 2, my y-intercept, and the slope is showing, again, negative 3, which I will show as negative 3 over 1. So that'll be down 3 to the right 1 from my ordered pair at 0, 2. So let's see, right here. Man, I had it. There we go. All right, but then it's down 3 to the right 1, right? So down 3 to the right 1, boom. Down 3 to the right 1. There we go. And I'll finish, though. Down 3 to the right 1, and then down 3 to the right 1. Okay, so that's to the right, but I can go the other direction. Left 1 up 3, left 1 up 3. And now these are pretty close, by the way, so I'm gonna use some technology to make sure these look at least kind of pretty. So let's see what we get then.
Yeah.
So I'll do the red line first through these. Oh, that's not the right shape. There we go. There's purple. There's red, and then purple next, right? So there's my purple one. Now these are close, but yeah, these are parallel lines. And we should have known they were parallel back here, just in case you didn't remember. Let's see if we can bring this back here. But the slope was the same, so we knew that they'd be parallel but we talked about this before, the y-intercepts are different, which means that these two lines will never actually intersect. There just is no solution for this one. So I believe on the homework, they'll say enter D and E for any like this that have no solutions. I don't mind just writing no solutions though, so there we go. So I'm going to start first with this top one. I'll do it in red, and it's already in slope-intercept form, which is very nice because it gives us then not just the y-intercept, but the slope. So the y-intercept I'll start with first because we would need the ordered pair on the graph before we can start the graph. And so 0, -1 is a good start. And then the slope, which is showing as -2. I will once again write -2/1 so that we can see the rise and the run. Since it's a -2, that will go down 2. And then the 1 for the run, it's positive, so it'll go to the right one. And again, see, I'm kind of almost forcing that denominator to be positive always. It's on purpose. And so I can graph 0, -1 right there, okay? And then I just go down 2 to the right one from there ever after, right? So there's some good ordered pairs for us to see, about as much as I can fit going to the right. I can copy the stair steps going to the left, here, 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 so many places, okay? So there we go. And, well, what the heck, I'll use technology again. It's not that I don't like it, it's just that I'm not usually very good at it. But there's a nice line right there, okay? And again, I graphed it. You could wait to graph it if you'd like, whatever. Now the next one we'll do in purple. And once again, we see both the y-intercept and the slope. So the y-intercept here is showing as a 0, 2. And it's just, the x value is always 0. Hopefully you're noticing that if you haven't yet. And then it's just whatever this value is with the sign to its left as its sign, the operation to its left as its sign. And then we also have a slope. We're going to show it as -1/2. You can make it 1/2 if you like, doesn't really matter. It's just, for me, the run will always be positive as long as I always assign the negative to the numerator there. So -1 for my rise means it's going to go down 1. And then the 2 for the run would be positive, so it's going to go to the right 2. From our ordered pair at 0, 2, right here, okay? So let's see, the way that I've got this, I would go down 1 to the right 2, down 1 to the right 2. Now, you'll notice as I continue to go down 1 to the right 2, that the two lines are diverging from each other, right? They're getting farther away from each other. Now, as long as you can notice that, even after a few points, you wouldn't necessarily need all those points if you're doing it by hand. You would see then, okay, I clearly need to go the other direction so that they will get closer, because if they get further away to the right, and they should get closer, the further to the left will go. So I'm going to make that, again, I'm just copying the stair steps. There it is. I found it, but the nerd in me won't let me stop, so I got to put these other ones on there. There we go. Got all of them. And here's some technology to graph the line. Hey, that's pretty good. Okay, and then I found the ordered pair right here, which appears to be the ordered pair -2, 3. So that is my solution. And again, we'll just go and throw those in there just to check, right? So if I replace x with -2 and the y value with 3, is that going to be true? So yeah, -2 times -2 is 4. 4 minus 1 is 3. Yep, that's true. And then the next one, right? X is -2 again, and the y value should be 3. We're checking for truthfulness. -1/2 times -2 is 1. 1 plus 2 is 3. So that checks off as true as well. And then I know for sure that the solution that we found, the ordered pair, is actually a solution, not just for one equation, but for both, as it should be. Yeah, hopefully that feels pretty good, especially if you guys got that right. You'll remember though, like all these are coming out very nice because it's being graphed. I'm not seeing any fractions or decimals. In the next section, which we will cover here momentarily, we'll see probably some fractional values. But we have strategies to deal with that. All right, now, again, we want you to be not so robotic on this stuff, any of this stuff really, that you just kind of start doing stuff, okay? Here's what I mean by that, is right here, remember, our ordered pair, I'll do it in green, but right at the beginning there, they told us what the y value is. How did I know that's the y value? Because it says y is -5. Boom. That's the only y value that'll make this one true. So it doesn't matter what the second equation is, it's the only y value that'll make the first one true, so it's gonna have to make the second one true as well. I can pretty much pencil that in as part of my solution, right? The only thing I need left is the corresponding x value. Now this kind of leads us into the next section. I'm not gonna do it actually, but that means you could replace this y, because remember, it has to make this one true, but it needs to make this one true as well. And the only y value that would make this one true is -5, because this one, I feel like I'm going in circles here, but hopefully you understand what I'm saying. You can replace this y with -5 and just solve for x if you wanted to do that, okay? Well, it does tell us that we have to graph it though. So I'm gonna graph it, and I'll do that first one in red, as pretty as it should be. Y is at -5, I found it. And so that's a horizontal line, right? All along this red line, that is where you will find y values that are -5. The x values, don't care. I don't really care what they are. I just know that along that red line, all the y values are -5. All right, well, what about the second line? We'll do that in purple. And yeah, it's already in slope-intercept form, so I know my y-intercept here is at 0, -9. It's an ordered pair. Then my slope, I guess we've seen the slope before, but -2, I'm going to show is -2/1, so it's down, 2, and then to the right, 1. From that ordered pair, 0, -9. Now you see a problem here, right? I go down 2 to the right 1, and I'm off the graph. So I actually got, I'm going to need to go in the other direction, but I'm going to copy my stair step, left 1 up 2, boom, found it. Left 1 up 2, there it is. I found the ordered pair, but so help me, I just can't stop, right? So left 1 up 2, left 1 up 2, left 1 up 2. Especially doing it by hand, you know, on the computer it'd be done, would have been done a long time ago, but the trials of being a nerd. So there's our line. Let's go and put the ordered pairs together. And now I see this ordered pair right here. And guess what the y value is? You'll never guess, man. It's -5. So it's -2, -5, specifically, right? Because there's my corresponding x value at -2. Let's go ahead and check. Let's check, right? So I got -2, -5. So what happens when I replace this y value with, I'll do green, with -5? See, it's the only value that would make that work, but it's true nonetheless. How about this one? Well, I said the x value should be -2, and then the y value should be -5. Let's check. So that'd be that's going to be +4 minus 5. Sorry, 9. Kind of jumped to the answer there. 4 minus 9 is -5. That also is true. So yeah, that's going to do it. Now on this one, it just showed y equals -5. That means if you ever saw an equation that said x equals a number, of course on the graph it's a straight vertical line, but that tells you immediately what the x value is for your solution, okay? And then again, you could, if you wanted to, you could just put that into the equation and solve for the corresponding y value. So this first equation here, I'm going to do, I'll do that one to make my red line. Let's just copy it down. So -2x plus y equals 1. And yes, I am going to change this one into slope-intercept form. Remember though, it's not actually a requirement that you do that. If you wanted to use the table and then find your ordered pairs to graph it, that's fine too. Okay, but right here I'm going to add 2x's to both sides. And yeah, that's going to do it for us because the y already has a phantom 1 there. So y equals 2x plus 1. It's not too bad. Then we need our y-intercept from slope-intercept form, which is at 0, 1 here. And then our slope, now instead of it being -2, which we've seen a lot of, we're going to make it 2/1. So the 2 is positive for my rise, which means it's up 2. And the 1 is positive for my run, so right 1, okay? So we can put this on the graph. At 0, 1, I got this point. And then from there, I'll go up 2 to the right 1. Up 2 to the right 1, there's my next point. Up 2 to the right 1. And yeah, we're just going to continue this pattern. Like this. And yeah, some of you I think noticed already what the final answer will be on this one, but just in case you don't, let's keep going, all right? There's all my ordered pairs, and I'll wait to draw the line there. So let's go to the next equation. 4x minus 2y equals negative 2. Now, if you have enough experience with equations, some of you, I think, would maybe even notice that you can divide all the terms by 2 just to simplify it. Let's pretend like we didn't know that, though, okay? So I'm going to solve for y, and then I'm going to subtract a 4x here, so minus 4x over here as well. Principles of equality stuff, that's going to zero out. I'll drop my negative 2y, which now equals, again, I want my x term first, and then the negative 2 second. Then I'll divide all the terms by negative 2.
That's what I was talking about earlier.
So yeah, that's where this comes into play. That's a phantom 1 now. And I am left with y equals, that's negative 4 divided by negative 2, which is positive 2, x. And then, yeah, even right here, it's a negative 2 divided by negative 2, which is positive 1 now. So some of you, I think, maybe even would stop at this point and say, look, at these two equations that are the same, not only is the slope the same, but the y-intercept is the same. What does that mean for us? Well, if I go to the line on the graph and I put points on there, there's my y-intercept. I'll put it down here too. Y-intercept at 0, 1 with the slope, and this is crucial that you notice now, it's not just 2, it's 2 over 1. It's the same exact slope, the same exact y-intercept, okay? So pretty much all the red points that I put on there are also my purple points. So we're seeing lots of different points of intersection, if I could connect them. And that would mean then that the line, both lines, they just intersect everywhere. So this one we would say just has infinite solutions. Because remember, the solution is the intersection. And if it intersects in infinite places, then it's just infinite solutions. So any ordered pair on, well, for one, would be a true state, would make the other equation true as well. Of course, now we can see that since we've kind of simplified them into slope-intercept form, they're the same exact equation, so naturally they would produce the same results.